How do we add, subtract, multiply, divide complex number? Let's we add complex number. Example. So here we have 3 plus 2i plus -1 plus 4i. So the way we add the complex number is by group the real numbers together and then group the imaginary part together. So now I group the 3 and the -1 together, and then I'm gonna group the 2i and plus 4i together. And also you want to use the bracket to show that, hey, this is the group. Okay, so the answer is just going to be 2 plus 6i. So how do we subtract complex numbers? For example, we're going to have 5 plus 4i minus 7 minus 5i. So we still want to group the real number together, and then we also want to group the imaginary part together. So here we're gonna move the 5 now. That because there is a negative sign in front of the group, make sure you distribute that negative sign to the group that is behind the minus sign. So on the inside, I have a plus 7. Because the negative side I have to distribute it in, it will turn into a minus 7. Okay. And then I'm gonna just keep the plus, and then we're gonna move the 4i, and now I have the negative 5i, and then plus another negative being distributed in, so that 2 minus psi will turn it into a plus 5i. So my answer is going to be a minus 2 or negative 2 plus 9i. So how do we multiply the complex number? Let's start with 6, 7. So here we have 6 minus 7i multiplied with a 2 plus 4i. We can use a box method, or we can use the distributive property to multiply the two complex number. But let's start with the box method that we have learned before. So here I'm going to draw the box 2 by 2. Now I'm going to put the numbers from one group to the side, and I'm going to put the numbers from the other group to the top of the box. Now I'm going to multiply it in. Okay. So 6 times 2 is 12. 6 times 4, 24 with the letter I. 2 times negative 7, negative 14 with the letter I. And then 4 times negative 7, negative 28. I times I to the second I square. I'm going to combine all of this. So it's going to be equal to a 12. Now the 24i and negative 14i, I'm going to combine those two together, turn it into positive 10i, and I'm going to rewrite the minus 28i squared. What we have learned about the imaginary number is the I squared equal negative 1. So we cannot leave the answer as negative 28i squared. We have to replace the I squared with a negative 1. Now negative 28 times negative 1 would turn into a positive 28. I'm going to combine with the 12. I will get 40 plus 10i. All right, let's move on to divide complex numbers. So let's start with something. Um, the first example will be 1 over I. So it doesn't seem like there's nothing we can do here. But dividing complex number means we don't want to see the letter I on the bottom of the quotient or fraction you want to call it. So what we can do is we're going to multiply this with, so I'm going to rewrite the 1 in I. I'm going to multiply the bottom with the I, and I'm going to multiply the top with the I. That doesn't change anything, right? But look at the bottom. So now 1 plus I is going to be I to the numerator, and I times I is going to be the I square. Okay, now we have an I over I squared is negative 1. So now we divide I to a negative 1 will be negative I. Okay, all right. Example B. So here we have 6, 7. Here we go. 6 plus 7i times 6 minus 7i. Okay, now after today, I want you guys to memorize this. The grouping between 6 plus 7i times 6 minus 7i, that look like this. It look like if you have an A uh, plus a B, a number B, times A minus a B, equal to A squared minus B squared. So the difference, the product of a difference, the sum equal to the difference between two squares. Okay, so that's what we call it. So now we can match in the 6 and 7 with A and a B. Okay, so it's going to be equal to 6 squared minus 7i squared. So be careful to keep the 7i inside the bracket. So here we have 36. Now I'm going to distribute that second exponent in slowly so you can see what happened in here. So be 7 squared and I squared. Okay, and that will give us 36. Now the 7 squared is 49, and the I squared is a negative 1. So we have 49 times a negative 1 with the negative will turn it into a positive 49. Do you see what I'm doing? So it's like this, okay? If you want to break it down, it's going to be like this, 49 times negative 1. Okay, so that ends up to be 36 plus 49. So that's going to give us 85. Okay, so we want to use this example B to divide or simplify the complex number. For example, I have something like this. So example C. So now I have, okay, a negative 2 divide 3 plus I. So the only way we would like to do this would be multiply something that we're about to learn, that is the conjugate. So what is the conjugate? So for example, the conjugate of 3 plus I. So the conjugate of 3 plus I is 3 minus I. Okay, so the conjugate of, let's say, 5 minus 7I is going to be 5 plus 7I. So the conjugate of a complex number is where we want to keep the real number, but we switch the size of the imaginary part. Okay, so we use the conjugate to simplify the quotients in the complex number. So we're gonna multiply the bottom with its conjugate, but we also want to multiply the top by its conjugate. So that's what the conjugate is. Alright, let's keep going. So now on the top, I'm going to multiply this out. So negative 2 times 3, negative 6. Negative 2 times a negative I with positive 2I. On the bottom, I'm using what we learned from example B. Okay, so I'm going to have 3 squared minus an I squared. Okay, so the numerator, the top, is perfect. We're not doing anything silly to it. Now on the bottom, 3 squared is 9, and then the I squared is minus 1. Okay, and then we keep going. We're going to keep the numerator as it. On the bottom, 9 minus negative 1. Now turn negative 1 into a positive 1. So 9 plus 1 is 10.